Replacing a fuse box with a circuit breaker panel raises several considerations, especially regarding existing electrical deficiencies in the house. Generally, simply replacing the fuse box with a circuit breaker panel doesn't legally mandate a full house electrical upgrade. However, an inspector might identify potential hazards. If unsafe conditions are found, like ungrounded outlets or exposed wiring, the inspector could require these specific issues to be addressed before approving the new panel. The inspector could also recommend upgrades to meet current electrical codes, but they can't force the homeowner to do them. The homeowner has the option to decline the additional work. Touching the subpanel could expose you to liability if ungrounded outlets or other electrical problems are discovered. This could result in legal responsibility for accidents or fires caused by the unsafe electrical conditions. Also, your insurance company could refuse coverage if they determine the electrical system isn't up to code. To mitigate these risks, firstly, inform the homeowner about the inspector's concerns and the potential risks. Emphasize that they aren't legally obligated to upgrade, but it's highly recommended for safety and insurance. Secondly, before touching the subpanel, create a detailed inspection report documenting any electrical deficiencies you observe. Thirdly, get written consent from the homeowner acknowledging they've been informed of the risks and are choosing not to upgrade the wiring. Fourthly, limit your work to the fuse box replacement, avoiding other electrical components unless required for safety. Replacing a fuse box doesn't automatically require upgrading the entire house. Awareness of the risks is critical, as is taking precautions to protect yourself and the homeowner. Proper communication and documentation can minimize liability and ensure electrical system safety. When dealing with ungrounded outlets, remember the importance of grounding for electrical safety. Grounding provides a path for fault current to return to the source, tripping a breaker or fuse and preventing electrical shock. Ungrounded outlets lack this safety feature, increasing the risk of shock or fire. The National Electrical Code, or NEC, provides guidelines for electrical installations, including grounding requirements. While not always retroactive, meaning older installations don't necessarily have to be brought up to current code, addressing ungrounded outlets is highly recommended for safety reasons. When replacing a fuse box with a breaker panel, ensure the new panel is properly grounded. This often involves connecting a grounding electrode conductor from the panel to a grounding electrode, such as a ground rod or water pipe. The size of the grounding electrode conductor is determined by NEC Table 250.66 based on the size of the service entrance conductors. Breaker panels offer several advantages over fuse boxes, including easier overcurrent protection management. Breakers trip automatically when an overcurrent occurs, while fuses must be manually replaced. Breakers can also be reset, while fuses are single-use. When selecting a breaker panel, ensure it has sufficient capacity for the existing and future electrical loads. Consider the number of circuits needed and the amperage rating of the panel. The NEC provides guidelines for calculating electrical loads to ensure the panel is properly sized. The main breaker in the panel should also be sized appropriately to protect the service entrance conductors. When working on electrical systems, always follow safety precautions. Firstly, turn off the power at the main disconnect before working on any electrical components. Secondly, use insulated tools to prevent electrical shock. Thirdly, wear appropriate personal protective equipment, such as safety glasses and gloves. Fourthly, test all circuits to ensure they are de-energized before working on them. If you are not comfortable working on electrical systems, hire a qualified electrician. Ignoring electrical deficiencies, like ungrounded outlets, can create safety hazards and potential liability. Documenting these deficiencies and informing the homeowner is crucial for protecting yourself and ensuring the safety of the electrical system. If the homeowner chooses not to address the deficiencies, obtain written consent acknowledging the risks. The NEC provides minimum standards for electrical safety. While older installations may not meet current code, addressing safety concerns is always recommended. Replacing a fuse box with a breaker panel provides an opportunity to improve the safety and reliability of the electrical system. Ensure the new panel is properly grounded and sized to accommodate the electrical loads. Always follow safety precautions when working on electrical systems. When discussing electrical systems, voltage, amperage, and wattage are key concepts. Voltage is the electrical potential difference measured in volts. Common voltages in residential wiring are 120 volts and 240 volts. Amperage is the electrical current measured in amps. The amperage rating of a circuit breaker or fuse indicates the maximum current the circuit can safely handle. Wattage is the electrical power calculated by multiplying voltage by amperage. Appliances and electrical devices are typically rated in watts. When sizing circuit breakers and wiring, it's important to consider the wattage of the connected loads. The NEC provides guidelines for calculating branch circuit loads to ensure the wiring and breakers are properly sized. Overloading a circuit can cause the breaker to trip or the fuse to blow, and can also create a fire hazard. Electrical boxes are used to enclose electrical connections and protect them from damage. Boxes are typically made of metal or plastic and come in various sizes and shapes. The NEC specifies the minimum size of electrical boxes based on the number and size of the conductors entering the box. Properly sized boxes are essential for preventing overcrowding and ensuring safe connections. When making electrical connections, use appropriate wiring methods and connectors. Wire should be properly stripped and connected to terminals or splices. Wire connectors, such as wire nuts or terminal blocks, should be used to ensure secure and reliable connections. Avoid loose or poorly made connections, as they can create heat and potentially cause a fire. Conduit is used to protect wiring from physical damage and moisture. Conduit can be made of metal or plastic and comes in various sizes and types. The NEC specifies the types of conduit allowed for different applications. When installing conduit, ensure it is properly supported and secured. Underground wiring requires special considerations to protect it from moisture and physical damage. Underground wiring should be installed in conduit or direct burial cable. Direct burial cable is specifically designed for underground use and has a moisture-resistant jacket. The NEC provides guidelines for burying wiring at the proper depth to protect it from damage. When working with aluminum wiring, special precautions are necessary to prevent corrosion. Aluminum wiring expands and contracts more than copper wiring, which can loosen connections over time. Use connectors specifically designed for aluminum wiring and apply an antioxidant compound to prevent corrosion. Labeling electrical panels and circuits is important for safety and convenience. Label each circuit breaker or fuse with a description of the loads it serves. This makes it easier to identify and troubleshoot circuits in the future. Panel schedules are commonly used to document circuits and their corresponding loads. Ground fault circuit interrupters, or GFCIs, are used to protect people from electrical shock. GFCIs detect ground faults and quickly interrupt the circuit, preventing electrical shock. GFCIs are required in bathrooms, kitchens, and other areas where there is a risk of water exposure. Arc fault circuit interrupters, or RFCIs, are used to protect against electrical fires. RFCIs detect arc faults, which are dangerous electrical arcs that can ignite flammable materials. RFCIs are required in bedrooms and other areas where there is a high risk of fire. Surge protectors are used to protect electronic devices from voltage spikes. Surge protectors divert excess voltage to ground, preventing damage to sensitive electronics. Surge protectors are available in various types, including whole house surge protectors and plug-in surge protectors. Smoke detectors are essential for fire safety. Smoke detectors detect smoke and sound an alarm, alerting occupants to a fire. Smoke detectors should be installed on every level of the home and in each bedroom. Carbon monoxide detectors are used to detect carbon monoxide, a colorless and odorless gas that can be deadly. Carbon monoxide detectors should be installed near sleeping areas. Regular maintenance of electrical systems is important for safety and reliability. Inspect wiring, outlets, and switches for damage. Replace any damaged components immediately. Test GFCIs and RFCIs regularly to ensure they are functioning properly. Keep electrical panels and equipment clean and free of dust and debris. When hiring an electrician, choose a qualified and licensed professional. Check the electrician's credentials and references. Ask for a written estimate before work begins. Ensure the electrician is insured and bonded. Obtain a permit for any electrical work that requires it. Permits ensure that the work is inspected and meets code requirements. Be aware of common electrical hazards such as overloaded circuits, frayed wiring, and damaged outlets. Take steps to prevent these hazards and protect yourself from electrical shock and fire. Educate yourself about electrical safety and follow best practices. This will help you maintain a safe and reliable electrical system in your home. The NEC is updated every 3 years to reflect changes in technology and best practices. Stay informed about the latest code requirements and ensure your electrical system complies with them. Electrical codes are in place for the safety of people and property. Adhering to these codes will minimize the risk of electrical hazards. When performing electrical work, always prioritize safety and follow established procedures. If you are unsure about any aspect of electrical work, consult a qualified electrician. Electrical systems are complex and can be dangerous if not handled properly. Proper planning, execution, and maintenance are essential for a safe and reliable electrical system. By following these guidelines, you can ensure the safety of yourself, your family, and your property. Remember, electricity is a powerful force that must be respected. Approach electrical work with caution and always prioritize safety. If you are not comfortable working on electrical systems, hire a qualified electrician. There are many resources available to learn more about electrical safety and best practices. Consult the NEC, electrical safety organizations, and qualified electricians for guidance. Electrical safety is a shared responsibility. By working together, we can prevent electrical hazards and create a safer environment for everyone. Regular inspection and maintenance of electrical systems can identify potential problems before they become serious hazards. Take the time to inspect your electrical system and address any issues promptly. Replacing a fuse box with a breaker panel can improve the safety and reliability of your electrical system. Ensure the new panel is properly grounded, sized, and installed according to code requirements. Always follow safety precautions when working on electrical systems. Electrical work requires knowledge, skill, and caution. If you are not qualified to perform electrical work, hire a licensed electrician. Electrical safety is not just about following rules and regulations. It is also about using common sense and making informed decisions. When in doubt, consult a qualified electrician.